Hello one and all, my name is Santosh KS and my partner name is Vinayaka S. Shastri. We are from Ambedkar Institute of Technology, 8th SEM, Triple E Department. On the project by Emergy, we are presenting about car black box, the event data recorder. Let's get into the contents of the presentation. It includes introduction, features of the black box, requirements, embedded system, microcontroller and microprocessor, PIC sim lab, project implementation, and at the last, conclusion. Now let's get into introduction about black box. A black box is either physically installed or installed in a car or downloaded as a smartphone app. It links to a GPS device that measures and records vehicle speed, location, distance traveled, driving frequency, and the time of the day the car is in motion. This is the pictorial representation of car black box system. Next, let's talk about the core features. Firstly, it includes GPS tracking. That is, it always tracks your vehicle or fleet using the inbuilt GPS of the device right from the web dashboard or through the mobile app. Next, it includes the track on demand, which is dynamically switch on and off tracking, and it alerts through the app. It also gives an notification about rash driving alerts. That is, it updates about the driver's driving behavior by getting alerts for over speeding, sharp acceleration, hard braking, sharp turns, etc. Then it also announces the panic button, which is similar to an SOS alarm. Panic button sends your location to your family or friends in case of vehicle breakdown or any emergency at just the push of a button. Engine immobilization via SMS or app. This is the engine cutoff with one touch on the app, which is useful for cases of vehicle theft or unauthorized use. At the last, eSIM, that is the embedded SIM. Vehicle black box comes with the ability to support eSIM, which is mandatory for AIS 140 standard. Next, let's get into the requirements which is required for the car black box presentation. That is the knowledge in embedded C, MPLAB IDE, XC8 compiler, PIC SimLab, default screen, login screen, main menu, view log, set time, and at the last, event capture. Let's talk about embedded systems. An embedded system is a microcontroller or a microprocessor based system which is designed to perform a specific task. Embedded systems may also function within a larger system. The system can be programmable or having a fixed functionality. The purpose of embedded system is to control a specific function within a device. They are usually designed to only perform this function repeatedly, but more developed embedded systems can control entire operating system. This is the classification of embedded system. It includes two types, based on performance and functional requirements, and based on the performance of the microcontroller. Based on performance and functional requirements include real-time, standalone, networked, and mobile. Based on the performance of microcontroller, it includes small scale, medium scale, and sophisticated. Next, the presentation will be continued by my teammate Vinayaka S. Shastri.
Thank you, Santosh. I will be continuing the remaining topics of car black box project. This includes leading factors to choose embedded systems. The factors that influence the embedded systems are low power consumption, cost efficiency, efficient use of processing power, reliability, and the last, efficient use of memory. Let's talk about microcontroller and microprocessor. These are an integrated circuit which is capable of being programmed to perform a specific task. It has a design restrictions such as memory size, input-output capabilities, peripheral functions, etc. To choose, we can choose microcontroller based on our application, performance, price, availability of tools, and for special capabilities. Let's talk about microprocessor and microcontroller, as well as we can compare these two. Microprocessor acts as a heart of computer system, whereas microcontroller acts as the heart of the embedded system. Microprocessor should be connected input and output component and memory through externally, but in case of microcontroller, it has inbuilt or internally present input-output components and memory. Since memory and input-output components is connected externally in microprocessor, therefore the circuit will be more complex and unreliable. In case of microcontroller, since on-chip memory and input-output components is available, therefore the circuit is less complex and it is somewhat like compact. Microprocessor cannot be used in a compact system, therefore microprocessor is inefficient. But in case of microcontroller, it is a compact system, therefore microcontroller is more efficient. Microprocessor has fewer registers, therefore most of the operations are memory based, whereas microcontroller has more registers, therefore a program is easier to write. The microprocessor have a zero status flag, whereas microcontroller has no zero flag. Microprocessor can be mainly used in personal computers, whereas microcontrollers can be used in controlling systems such as washing machines, air conditioners, IoT devices, etc. Here we are going to use microcontroller named PIC-SIM-Lab. PIC-SIM-Lab is a real-time illuminator of development boards with integrated MP-Lab X or AVR GDB debugger. PIC-SIM-Lab supports some PIC-SIM microcontrollers and some SIM-AVR microcontrollers. PIC-SIM-Lab have integration with MP-Lab X or Arduino IDE for programming the board's microcontrollers. PIC-SIM-Lab supports several devices that can be connected to the boards for simulation, as for example LEDs and push buttons for some outputs and inputs, and some more complex ones like Ethernet shield W5500 for internet connection, or the color graphic display ILI 9340 with touchscreen. You can see the block diagram of PIC 165877A, which contains RS232, LEDs, buzzer, digital keypad, SSDs, keypad, CLCD, analog to digital controller, LM35 temperature sensor, 12C RTC EEPROM, GP10. Let's see about the function of before talking about functions of PIC 16F877A, let's talk about the software which we are going to use in this project, that is MP-Lab X IDE. Microchip technology MP-Lab X integrated development environment, that is IDE, is an expandable, highly configurable software program that incorporates powerful tools to enable designers to discover, configure, develop, debug and qualify embedded designs for most microchip controllers, that is MCUs, and digital signal controllers, DSCs. The flexible and customizable MP-Lab X IDE interface allows you to have multiple debug tools connected to your computer at the same time. You can select any tool you desire for a specific project or configuration within a project. With complete project management, visual call graphs, a configurable watch window, and a feature-rich editor that includes code completion and hyperlink navigation. MP-Lab X IDE is fully equipped to meet the needs of experienced user while remaining flexible and user friendly for even those who are new to the IDE. Let's talk about project implementation. The project implementation, as I said earlier, we are going to talk about PIC 167877A, that is Pigenius board from Microchip. It contains hardware like LEDs, digital keypad, interrupts, timers, clock, SSDs, CLCD, matrix keypad, analog controllers, that is analog to digital converter. The PIC 16F877 has following. We are going to talk about the functionality about this microcontroller. It is of 8-bit. It contains 5 ports, namely port A 6-bit, that is it is analog. Port B 8-bit, it's bidirectional port. Port C, it is also 8-bit. Digital pins used for serial communication. Port D 8-bit, all are digital pins. The softwares used are MP LabX XID, XC compiler, TIC similar. Let's move on. The functionality also includes displaying wrong password, displaying of wrong password, and main menu, log. Let's talk about the applications of this black box, that is car black box specifically. The car black box can be installed in some automobiles to record various events. The events may be of accidents or rash driving, or any disastrous or dangerous events that can be harmful for the passenger as well as driver. These events, which are electronically sensed, can often proactively detect any issue in the vehicle, that is maybe of technical issues like engine fault, or monitor the fleet, that is our driver or passenger, thereby doing proactive